I am going to review the line of best fit in this video, and this could serve as just an instructional video for line of best fit as well. So this here I have is a piece of dental floss. I actually usually use spaghetti, but I don't have any here with me. So I'm going to use a piece of dental floss, and you don't have to have something, but this is just what I'm going to use to demonstrate. So what's happening is we have a scatter plot, and each scatter plot is going to have either a positive or a negative correlation. And that's because we wouldn't do a line of best fit for a scatter plot that has no correlation. So you're going to have scatter plots that have positive, have negative, some of them are going to be stronger, some of them are going to be weaker, and that doesn't matter, but we won't have any scatter plots that have no correlation. So what we're going to do, the whole idea behind a scatter plot and finding the line of best fit is that this is a survey, and these are different people. The survey was asking how long they studied and what their score was on the test. So obviously from a teacher standpoint, the more you study, the better you do. So this has a positive correlation because the more you study, the higher your score. The less you study, the lower your score. So they're moving in the same direction. So the correlation on this one is definitely a positive correlation. So what that means is that we want to find a line that would give us an equation for the relationship between how long you study and what you get on a score, for your final. But in this situation, this is just talking about this test. So this wouldn't work for every test. This is just on the people that were surveyed for this. So what we're doing when we do a line of best fit is we're trying to figure out where could we put a line on this graph that would represent the scatter plot. So something like this would not make sense because if this was the line, the points are all above it. We established it's a positive correlation, so a line with a negative slope is not going to make sense. So we definitely want a line that has a positive slope. But what we need to do is figure out where should we put it. I think this one is a little steep for this set of information. I think this one would be a little bit low. Something like this is probably not steep enough, and it's a little low. So we want to just decide where we think a good representation for this test would be. And you don't have to completely split the points half and half, but you do want to have scatter plot points on both sides of your line. So what you need to do is pick 2 points on the graph and have your line connect those 2 points. So if I look at this right here, I think I might choose those 2 points. Now, you don't have to choose scatter plot points. You could pick grid points. So maybe I would pick that point right up there, so right there, and maybe another point. So this doesn't work quite as well as the spaghetti, but you get the idea. So maybe I would do something like this, but it doesn't matter as long as you pick 2 points because you have to have 2 points to draw a line. So I think I might go with this. So I'm going to use this point that isn't actually a scatter plot point along with this one. So first thing I'm going to do is mark the 2 points that I'm using. And I usually mark them with an X. All right, so next thing I'm going to do, and I'm just going to use the edge of my paper here to draw my line. So if I can get it going the right way, the line that I'm using, whoops, looks something like that. All right, so now what we want to do is figure out what is the equation of this line. Because once we do that, we could use this line to predict the score based on how many hours somebody studied. All right, so in order to find the equation of the line, remember we are looking for y equals mx plus b. So what we need to do is figure out what the m is, which is the slope, as well as the b, which is the y-intercept. So since we have these 2 points, first thing we need to do is figure out what is the slope between those 2 points. We can subtract them, which is easy, or we can just follow the graph. And remember, slope is rise over run. So we're going from 50 up to 90. So that alone, you can tell we're going 40 points. So we're going to go up 40 points, and over, we're going from 1 to 8, which would be 7. So our rise over run is going to be 40 over 7. So you do have to pay attention to these points. Even though we went up 4 spaces, the value of those 4 spaces would be 40. So the slope of our line is 40 over 7. Now, if we could reduce that, we would. We can't, so we're going to leave it. All right. Next thing we need to do is figure out the y-intercept of our line. Well, the easiest way to do that, and we could mathematically put it back in, but I think we can just eyeball it. Here is the y-intercept right here. So if I look at that, that's almost halfway. It's a little less than halfway between 40 and 50. So I'm just going to say that my y-intercept is 44. So now I can write the equations. So y equals my m times x plus b. So that is the equation of the line that I drew. Now, what's important to remember is if you pick different points, you're going to get a different equation. So it's not necessarily wrong, but you just need to keep in mind that if you picked different points, your slope's going to be different, and then the y-intercept is likely going to be different. All right, so the next thing says, predict the score of a student that studied 15 hours. Well, the hours spent studying is our x. So all I'm going to do is fill in 15 for x. So I'm going to do 40 over 7 times 15, which you can put is over 1, and then plus 44. 44. Okay, so if we work this out, so let's see, 40 times 15, so 4 times 15 would be 60. So that should be 600 over 7 plus 44. All right, so let's estimate that. So, So 600 over 7 is a little more than 85. So I'm just going to say that's approximately 86 plus 44. And then that would mean that our person made a 130. Now, this goes to show you the validity of an equation like this. This equation appears that it's going to continue to go up. So someone that studied 15 hours might be out here, their score would be way up here. The problem is that it doesn't make sense. So just keep in mind that this is just a way to predict what might happen, but it's not necessarily going to be accurate. All right, let's go to the next one. So again, first thing we want to do is look at the scatter plot. We can tell by looking at this one that we have a negative correlation on this scatter plot. So the correlation is negative. All right, so now I'm going to take the dental floss. So I want to put the line somewhere that I would say is the middle and follows the trend of the data. And again, you don't have to pick exact points, but you can. And I think I might do kind of similar to what I did on the last one. Let's see, I might use this top point and that point right there. Or we could easily use those two. Now, a reason why I'm looking for points that meet right on the grid marks, because I'll definitely know what their values are. So I think once again, I'm going to use a point that is not on the scatter plot with a point that is on the scatter plot. All right, so what we need to do is write y equals mx plus b. So the first thing we need to do is rise over run. So if we follow up this way, we're going from 15 up to 90. So that's going to be, oh my gosh, 75. And then we're going left from, where are we going? From 50 to 10. So we're going to go left 40. Since we're going left, that counts as a negative 40. So the slope for this, oh no, I forgot to draw my line. So the slope for this is going to be 75 over negative 40. So if we go right here, it's 75 and it's negative over 40. But we can reduce that definitely by 5. So that will be 15 over 8. And I did forget to draw my line. So again, I'm just going to fold my paper up to use it as a ruler. And let's see if we can get those two in a good spot. Okay, so I'm estimating this for my line. Okay, so we got our slope is a negative 15 over 8. All right, so now we need to figure out the y-intercept. Well, here's the deal. It's off the graph. I'd say it's right about there. And if we look, we're going up by 15, which means this right here would be 105. So I might call this 108. So I'm going to say that the y-intercept is 108. So now the equation of the line is y equals negative 15/8 x plus 108. All right. Next graph. So this one, again, looks like it is or has a negative correlation. This one is not going to be quite so easy because there are no grid lines. So we're really going to have to estimate the points, which isn't ideal. But all right, so let's see. Now, we don't want these outliers to pull our line too far, but I'm thinking maybe something like that. So I might use this time, I'm thinking, let's see, I can get it to go straight here. Let's see, I think I might go with this one. This one's okay. These kind of are same distance from over here. So I think this time I'm going to use that point right there and that point right there. So again, what's difficult about this is getting the points since it's not perfect. All right, so again, I'm just going to fold my paper down. See, you guys like to say using your resources. This is an example of using your resources. And then I'm going to trace the side so I can get my line, okay? All right, so let's see. First thing we need to do is figure out the slope. So let's see. I would probably say this point is not quite at 80, but just for ease, I might say this is at 80. And let's see, if this is 300 and that's 350, I might say this is 325. All right, and then this point here is not, here's 25. It's not that far off from 25. And then it looks like if this is 550. So, I might just call this 25 and 500 because this one is going to be a little bit harder and we don't want our slope to be like way too messy. All right, so we need to figure out rise over run. So here's the deal. This is where subtracting comes into place. We need to go from 325 up to 550. So 325 to get to 550 would be a rise of 225. And then we need to go left, and we're going from about 80 down, down to 25. So we're going from here to here. So 80 down to 25, and we're going to the left. So that should be negative 55. So then that is going to give us our slope, which is the rise over the run. And then, again, it should be negative because our correlation is negative. But then the other thing is that we can reduce this. So if we, let's see, I know 5 will definitely go into both of those. So 5 will go into that 11 times. It is negative. 5 will go into that 45 times. So that gives us our slope. Now we have to figure out the y-intercept of our line. So I'm going to go right up here, and again, if this was about 550, I'm just going to say it's 575. So the equation is going to be y equals negative 45 over 11x plus 575. All right, I think time-wise I need to get this video stopped. Hopefully you get the idea of how you can find the line of best fit.